Hi, everyone. Welcome to What Can I Do with 5G That I Can't Do with Wi-Fi 6 or Industrial Ethernet. I'm joined by Tadhg Kenny of Druid Software, Sander Rotmensen of Siemens, Stephen Muldowney of Athonet, and Timon Sloane of the Open Networking Foundation. So getting right into it, I thought the best place to start this conversation would be some of the technical details. So Sander, can you kick us off by diving into the features of 5G and Wi-Fi 6, focusing on what they have in common, but also the key ways in which they differ?
Yeah, of course I can. So let me start very simple. So they're both wireless technologies. So I think that was an easy one. But there is more they have in common. So both are very useful in industrial environments, because we speak about manufacturing here. For example, with Wi-Fi 6 now, the newer generation of devices, we have solutions like target wake time, which can help us with battery saving solutions. We have multiple devices being able to talk to the access point at the same time, reducing airtime. So there's better latency guaranteed, for example, with Wi-Fi. A difference with 5G will be Wi-Fi is purely ISM band based, it means unlicensed spectrum. So you have to share the spectrum with others, whereas 5G is at the moment still a licensed spectrum solution. 5G focuses on three main scenarios: enhanced mobile broadband, massive machine type communications, and ultra reliable low latency communication. It sounds like it does high bandwidth, low latency, maximum number of devices all at the same time. We have to be quite clear about that one as well. It's not quite true, because if you want to have the highest bandwidth, you cannot have the maximum number of devices connected, nor the lowest latency. And these are things you need to think about as well when you lay out the network. Like a cool thing about 5G is that it can be run in a public as well as a private network. And I think those are very interesting solutions. And maybe one thing to note down is 5G in a private setting is not available in every country yet, because we do not have spectrum available all over the world. That's a pity, and that's a benefit of Wi-Fi 6. You can use it literally everywhere in the world.
Okay, thank you. I think that really kind of helps set the stage for some of the things we're going to talk about, which you mentioned. We'll dive a bit deeper into those. So, Timon, when we talk about 5G in manufacturing, we're talking about Industry 4.0 and enabling developers to go after this next level problem of connecting machines to devices on a larger scale. So looking ahead and drawing from the title of this panel, how can 5G, as opposed to Wi-Fi 6 or Industrial Ethernet, help address these next level problems?
Yeah, so good question. So, I think the higher level vision that everybody's really excited about is connecting, machines to devices and applying AI and ML to devices to do things like predictive analytics. Imagine a set of sensors on machinery and measuring temperature and vibration, and then kind of starting to just recognize patterns that, hey, this pump needs to be serviced or it's going to fail. And there are some high, and exciting expectations that this can be really a grand enabler on a grand scale, and huge industry projections about billions of dollars. This is really what people are calling Industry 4.0. So to do this, you need to be able to connect, all of your important assets, and so wireless technology is really ideal for that. And 5G is really getting tagged for being, ideally suited for this. And you need to be able to connect those devices in a much more reliable, mission-critical kind of way. And for all the different types of, massive numbers of devices. And Sander mentioned that as well. And then ultra low latency for things where you're getting into sort of active control. And so, 5G really is ideally suited for it. At least I'll speak personally. I go into an airport, I don't even try to use Wi-Fi. You get into a crowded environment where people are just coming in with their own cell phones, and it just creates noise and contention, and things are unpredictable. You can have 4 bars and still can't even read an email. Whereas, cellular networks are just much, much more predictable. And we need that predictability for Industry 4.0. And that, in summary, that's why 5G really is ideally suited for this next wave of innovation.
Okay, great. And you talked a lot about the next wave of innovation, but I think it's also important to talk about what 5G can do today for manufacturers. So, Stephen, what would you say to those manufacturers that consider this conversation to be one only for the future? How can 5G benefit manufacturers today? And how can manufacturers tell the difference between use cases better suited for 5G or for Wi-Fi?
Yeah, no. Well, I think that first to start off is that 5G is being used today by manufacturers across the globe. So it's not something that is a future consideration. A number of organizations have adopted it and are seeing the benefits of it today. Now, as Sander said, that this is an evolving specification. That there's bringing some new features in as it develops. So the key one that people focus on and say, why 5G is not relevant for manufacturing today is sort of the ultra low latency. That is coming in future releases, but that doesn't stop you from doing automation today. So you can use 5G for automating in terms of cranes, robots, AGVs. We have seen that it deployed. So there's a very famous sort of steel factory in China that basically automated its cranes and saw a 25% increase in efficiency and a 5% reduction in material usage. We've seen the high bandwidth of 5G offers being utilized by the likes of Haier and Comac for camera inspection. So being able to mount very 8K cameras across the sort of the assembly line, looking for defects that the naked eye wouldn't be able to do, and be able to do it much quicker. So they've been able to reduce the sort of the amount of systems and reduce the labor cost by increasing the quality of the lines across there. So I think we're seeing it today. The key thing is that they can look at the going to the point about the sort of what does it bring else, is around looking at that sort of the comparing, as we said earlier, about the license versus unlicensed. And the license gives that predictability, the security, the reliability, but also the mobility, and that allows you to do those use cases I talked about, which is the robotics, the automation, the crane that factories are doing today and seeing the benefit of. My last example would be the project that was done in the UK with Worcester Bosch, and they said that they have an average sort of 2% efficiency gain that you see they're looking for, and normally they have to do 100 different items each year to achieve that. By putting the 5G and doing sort of their predictive maintenance, they were able to reduce, do over 1% of that in one big sort of project, rather than, and that's a great benefit to them.
Thank you. And something that you mentioned and Sander mentioned was this conversation around unlicensed versus licensed spectrum. And I want to dig deeper into that with my next question for Tadhg, because I think that is a big differentiator between the two. Wi-Fi utilizes unlicensed spectrum, cellular typically uses licensed spectrum. So Tadhg, for our listeners in the manufacturing space, what is the implication of or the differences in deploying an unlicensed or licensed network at their facilities? Like, why is this something that they should care about?
Sure. Well, one of the main reasons they should care about it, Catherine, is because they can use both and they can gain competitive advantage in their manufacturing processes. Like behind me here, we've got the Port of Rotterdam video capture there of that running, Wi-Fi and 4G running there for 6 or 7 years. And they're using both to gain competitive advantage in the transport industry. So, especially in the US, where a lot of the audience is tuning in from today, there is unlicensed and licensed spectrum available here, and in many other countries right now. Unlicensed with Wi-Fi is more unprotected and is open to be used by other individuals, and thus interference can easily happen, while licensed spectrum with 4G and 5G has the benefit of being protected and ring-fenced for the exclusive use of the enterprise, especially in a private network scenario. Unlicensed for Wi-Fi is great in the sense that you can you fire it up anywhere, as Sander mentioned. You can use it globally. But for business critical use cases like those in the 5G smart factories and test beds that Druid are supporting, it can be a problem to use unlicensed spectrum. Why? Well, for example, I could go into that environment, fire up a Wi-Fi hotspot with my smartphone, as Timon said there, like in the airport example, try to get some work done, but inadvertently interfere with that carefully planned Wi-Fi network. So while licensed spectrum has been scarce in the past, the good news is that manufacturers in the US and in many other countries can use it today for business critical use cases. And then at the same time, they can unburden their unlicensed Wi-Fi networks.
Okay, thank you. And going back to Sander, I realize this is asking a lot because I'm requiring you to wear multiple hats in this conversation, but can you switch gears here for a second and focus on Siemens as a manufacturer rather than a technology provider, and share with us how, what you're able to share with us about how the company is navigating this question of when and how to use Wi-Fi within its own operations?
Yeah, that's actually, it's not a big problem for me because I visit many of our factories very often. So it's also one of the reasons I didn't wear a shirt today. And let me first start, at this moment, we use in production Wi-Fi. We have created Wi-Fi in a way that it fulfills the requirements of industry a bit better. We call these things industrial features, I-features, which are specifically developed to address the needs of Profinet, for example, where we need real-time exchange. So we are running this throughout our factories around the globe. We do test a little bit with 5G. So we have some test facilities in Amberg, for example, in our visitor center there. We testing it is in our showroom and automotive test center in Nuremberg, as well as we are deploying a 5G network in Karlsruhe, the plant where we manufacture all of our Siemens network components. They're really manufactured in Germany still, which I think is pretty cool. So that's what we are doing there. We're trying out how this works with those applications we can address with 5G today. And that is a very specific, it's the not mission critical applications at this moment because we do not have URLCC available, for example. So this is where we play with a little bit. And we can only do this in Germany because it's the only place where we have the spectrum available for 5G at the moment. And when we look, for example, at wireless LAN, or that's how we call it in industry typically, or Wi-Fi, we all of a sudden got this year a boost of availability in spectrum with the 6 gigahertz band. So now we have complete greenfield deployment where you can play with Wi-Fi without having to take care of legacy. And this is, of course, opening huge opportunities for us in the future. That's why we believe the world will be consisting of both technologies going hand in hand. And this is also based on the fact that we now, with wireless LAN or Wi-Fi, we have a 15 years install base in the field. And we cannot just take this out of the factory and replace with 5G because there's a new kid on the block. And with 5G, we don't have unlimited spectrum. But if you combine both together, we have a lot of spectrum available. And I think we can really mitigate the channel planning a little bit better in the unlicensed spectrum. Because, for example, in the US, we get up to, I believe it's a gigahertz of spectrum additionally. In Europe, it's over 500 megahertz of additional spectrum. It's more so what we had before with Wi-Fi. And I could see a world where we have mission critical applications in the future using the licensed spectrum. As Tadhg said, this is probably one of the best way to think about your drones, for example. But then, does a human being need to be connected in a mission critical way to have this 1 millisecond or below 10 millisecond latency? I don't think so, because we don't even refresh our emails that quick if we're waiting for an order delivery of one of the shopping centers online, of course. So there are a couple hundred milliseconds is not a problem. So therefore, I think it's going to be a nice mixture, and it's up to us to bring these technologies together and make sure they can be used by OT operators instead of telecom engineers. And this is where we are really striving for, and this is where we also work together with our factories to get this done. Because it's not as simple, we design something and they can use it. No, this is a work in progress which goes over multiple years. And I think with upcoming releases of 5G, we have some exciting things happening, but Wi-Fi will be there for years to come.
Okay, thank you for sharing that. And I do want to talk about OpenRAN because Wi-Fi does not offer an equivalent architecture here. So Timon, for you, how does OpenRAN impact the overall conversation about whether to implement 5G in place of a Wi-Fi 6 network?
Yeah, this really speaks to the origins of both technologies. When we see them coming together here in manufacturing and for the enterprise, which is why we're here today. But Wi-Fi came out of a consumer world. Independent devices, independent access points, cheap price points was really the foundation and origin story. Whereas mobile and 5G came out of telecom, massive worldwide networks, millions of users, need to optimize a very expensive spectrum and provide very reliable communications. And the end result is, I mean, the story I was using before about when I'm in the airport, just how much more reliable it is for me to use my cellular connectivity. I think that we all have experienced that. And so I agree, Wi-Fi is here. No, Wi-Fi is not going to disappear. Nobody's going to rip and replace Wi-Fi. But I think that we are on a path where 5G connected devices are going to be ubiquitous, and we're going to see kind of a massive movement towards 5G. And I could see, 5 years, 10 years down the road, where we have definitely seen a huge shift towards a more well-managed spectrum. Now, your question was around OpenRAN. And this is kind of speaks again to the origin that the RAN, the coordination of the radio network in the telco space is just much more highly optimized. I mean, all the radios are time synchronized. You can do handoff between where you don't even notice a call dropping, and that's what gives these telco networks their power and robustness. That has historically come from very tightly closed systems that were now kind of only available from a very small number of manufacturers with the amount of consolidation that's taken place. OpenRAN is a movement to open up the RAN network so that you have a set of compatible pieces, and you can mix and match components, and you can also extract the intelligence into software, something called a radio intelligent controller, or a RIC. And this is really exciting because this RIC can coordinate all of your radios. Imagine a factory floor, and you have drones flying around, and you want to be able to hand them off between radios and cell sites, but do it in a seamless way. Having this open environment that is all well coordinated, and we can start to build customized RICs for the different verticals, where you're in a mine or you're in a factory floor and you have different types of interference and different specific needs. We can really optimize the deployment for different use cases. And 5G offers this whole open RAN space, where it's not offered at all in the Wi-Fi space. It's antithetical to where Wi-Fi came from. And we believe, and we're seeing indications that this is going to be sort of a huge transformative advantage for manufacturing applications and industrial applications, for really being able to deliver the level of reliance and mission criticality that the industry needs and desires.
Yeah, I think you're right.
If I can add one thing,
yeah,
just in news, the German government has allocated 300 million euros on the development of OpenRAN. Specifically, a lot for that is going into industrial needs, manufacturing needs. And just today, they announced that they have 31 million already allocated for projects and real life proof of concepts going on. So OpenRAN is definitely important in the future.
Yeah, and I'll tag on to that ONF, we just announced that Deutsche Telekom's deployed a live field trial based on OpenRAN, 5G and 4G combined. We announced that in the last 3 weeks or so, and that uses components that come from ONF. So this is real, this is present, it's getting a lot of traction, and I think a very, very exciting space.
Yes, absolutely.
Yeah, absolutely. And as even with OpenRAN, as you all mentioned, Wi-Fi is not going anywhere. So it's of course important to talk, which you all kind of touched on, coexistence, convergence, all of that. So Stephen, if you could, talk to us more about what coexistence will look like. We had an audience question here asking about Wi-Fi 6 RAN convergence. If you could just touch on how they'll be working together a little bit more.
Yeah, sure. So, I mean, I think that, a factory or manufacturer will start off and just, segment it sort of its use case and design its network based around those use cases. So as you said, there will be coexistence. One is not replacing the other. You can look at and say the Wi-Fi is going to be segmented for that sort of non-critical, non-time sensitive services, where mobility isn't critical in terms of that time sensitive and critical nature of it. In fact, there are cases where we worked where the 5G is actually powering the Wi-Fi, so to providing the sort of the connectivity to it. So rather than having to sort of put in a separate network, but I think that what will happen is that the network will be designed around the actual the needs of the factory. So for example, if it's a brownfield site, a legacy site that already got some Wi-Fi, then, they want to extend the network, then they will basically, put an overlay around that. What we'll see is that, an increase where you've got moving to a single pane of glass where the factory will be, integrating all the systems into a single management platform, and that all can be done. The 5G core today from Athonet can be connected into the existing IT infrastructure. For example, to integrate the IP phone systems or the existing push to talk, that the critical comms that you still do find within a factory, manufacturing scenario. So I think in terms of that, we'll see that those as far as the manufacturer, they would just see this as their network, and that will have a number of access points within it, and they will design that out based on their needs. If they have a difficult environment where they need to reduce down the number of access points, then 5G is perfect for that. In these really difficult sort of environments, you might see a sort of needing 10 for every 10 access points, you might need just the one 5G. I mean, in sort of non-difficult environments, you can go to much greater numbers, 1 to 50, etc. So it simplifies their network as well. So I think, but going back to your point, I think what we'll see is that this, they'll segment their use cases, but as far as they're concerned, they'll still see that as one large network, but having certain services only associated with one network based on their use case, whether it's it needs that its critical nature, whether it's critical or non time sensitive.
Great, thank you. And Tadhg, so Druid software has been focused on fixed wireless access as a way to address the digital divide in the US, and primarily we're talking about residential applications. But how can this help Druid's more industrial customers? Is fixed wireless access something that manufacturers should be aware of, should be thinking about, should be considering?
Yeah, absolutely. And I think it's another great opportunity to talk about the combination of 5G and Wi-Fi 6 potentially. COVID has only accelerated the need for this rapid data delivery solution. Lockdowns highlighting the deficit of data provision to enterprise manufacturing, remote manufacturing. And also we see how supply chains have been affected. So more and more, as you say, more and more wireless internet service providers in the US in particular are using 4G with a view to migrating to 5G. With ongoing licensed spectrum. And here they can cover big outdoor areas rurally, but also address underserved urban areas. We don't think about those ones that often, but like in our city of Tucson deployment. So using 4G and 5G to provide data over large distances to the last mile to reach the enterprise and manufacturing campuses. And then routers can then access the 4 or 5G for business critical manufacturing or turn it into Wi-Fi with routers, as Sander alluded to. You can use Wi-Fi as well. So we see, heavy industries like wind farms, oil and gas, mining, and major utilities. They've been doing this for many years with 4G LTE. Some have even invested in their own licensed spectrum now with auctions in the US last year. So they have their own licensed spectrum rather than going to the regulator. And we see how energy providers have been one of the earliest adopters for smart maintenance, along with transport companies like the Port of Rotterdam use case you can see behind me, or the Port of Oakland in San Francisco Bay has followed them this year with our partners Geoverse. So in all these cases, they have succeeded in again, gaining competitive advantage by using 4G and 5G technology in combination with Wi-Fi, in a fixed wireless access use case.
Okay, excellent. And we have a couple minutes left. So I thought I would have all of you, or if you want to comment on the cost difference between deploying a 5G network or a cellular network and a Wi-Fi network, because I think this is something our listeners are probably thinking about. So Tadhg, if we could just go right back to you to kind of, have your comments on that, just so panelists are aware. We have 5 minutes left in total. So, mind your...
Yeah, I suppose I've got two answers, right? It can be comparable, especially in the example you see behind me here. When you go outdoor, it can cost an awful lot to try and do that with Wi-Fi because you need more Wi-Fi access points. They're shorter range. But in fairness, it doesn't tend to be an either or. Again, it's about combination. It's about why they're in some sort of pain. There's some sort of money loss using the Wi-Fi technology. So it's not about which costs more or which costs less. Wi-Fi is there anyway. and then they're looking at addressing the loss of finance with a business critical technology like 4 or 5G.
Stephen, go ahead.
Yeah, so I think just adding on to that, the Komatsu, I probably pronounced that wrong. They're the sort of the large industrial vehicle manufacturer. They used to control their vehicles by Wi-Fi, and they did a study where they'd lost each truck. So this is a mine, so it's a slightly different, but it's relevant in terms of this. And the downtime, because they lost connectivity to the Wi-Fi, was basically about 15% of a 24-hour period, which equated to about 13 minutes and 6 seconds. They talked about, and that equated to be around over 300,000 tons that was lost per year of productivity. So even if that network did cost, but it's an outdoor one, so it probably is quite efficient. But even if it did, there's a business case of that, the efficiency gains that you can have through that. In a factory situation, the predictive maintenance that allows you to basically gain back some of that, and maybe the additional cost that might be for some of these installations.
If I could jump in, I mean, I would say that we're hearing a lot of descriptions about why 5G can be more cost efficient, kind of with some secondary explanations. But the root cause is that 5G has come from these really closed environments, a very small number of vendors, and we're seeing huge transformation here. I mean, ONF is in the middle of driving open source for 5G. This DT network I described is composed of a mix of open and closed components. And we are on a path, and we think we can create networks that are substantially less expensive with 5G. I mean, you get better coverage, but when you can start to leverage open components, and with OpenRAN, once we start disaggregating the RAN and you can start to mix and match pieces, we're already seeing the price start to really shift dramatically. And so we are very strong believers that 5G will be much more cost effective in the not too distant future, and we can hit comparable price points right now today. And to that end, I'll just mention that ONF has just recently announced and spun out a commercial entity called Ananke, specifically to commercialize and make it as easy as possible to consume this, to make it as easy as Wi-Fi, plug and play, SaaS delivery of a 5G network, with the belief that this is a grand enabler for this whole Industry 4.0 movement as it's coming, and that we want to do everything we can to make it as easy as possible to consume.
Excellent. Sander, anything to add?
You're the only one that didn't. So no, of course I have. So I think it's not about the cost. And Stephen, your example, what we have seen very often that they use office equipment to run industrial tasks. So I think that's already where they go wrong very often. So industrial suppliers create industrial hardware to be run in industrial environments. So a good example is one run on Wi-Fi network from a office supplier, and it didn't work all of a sudden when it was raining. And they thought, oh, that's the interference of the rain, until they looked closer at the devices. They screwed them open and all the water came draining out of the device. And so there's also the things we need to think about. Sometimes it's not the wireless of it which is causing the problem, it's the kind of hardware we use. And therefore, we need to industrialize. We need to make sure everything is industrialized. We also need to make sure we're not taking a countrywide system and dumb it down to fit into the industrial world. We really need to develop something from scratch, and that's what we are doing. We are creating a from scratch build-up solution which fits for industry, and this is what we're doing with our industrial automation and knowledge in the background. So I think that is where we need to be looking at to really get that cost-effective network, be it 5G or Wi-Fi or a combination. We as Siemens truly believe in a combination of both, because more spectrum is more possibilities.
I think that is a great way to end. So thank you, gentlemen, and thank you for listening. Make sure to check out the next session for an update on 5G standards.